Hello everyone. In this video, we are going to discussing about the example problem on elastic constants. Let's see the problem. A bar of 25 mm diameter is subjected to pull of 40 kilonewtons. The measured extension on gauge length of 200 mm is 0.085 mm and the change in diameter is 0.003 mm. Calculate the Poisson ratio and the values of the three modulus. So let's see the solution. First we have to write the given data. Here I have to observe that one the cylindrical bar, which having the diameter of the 25 mm diameter and the subjected to pull is nothing but tensile load, which is the 40 kilonewtons, and the length of the bar is given 200 mm and the extension, say change in length is 0.085 mm and the change in diameter is 0.003 mm. So first I have to write down the given data. So given data is, first one is the diameter of the bar. Let us consider small d is equal to 25 mm. So then we have to calculate the cross sectional area. So which is the, let us consider cross sectional area capital A, which is the pi by 4 d square. So cross sectional area of the cylindrical bar is 490.87 mm square. And he applying the pull of 40 kilonewtons, which means tensile force, let us consider capital P 40 kilonewtons, which is 40 into 10 cubic newtons. Then the gauge length, so length of the bar is, let us consider capital L, that is the 200 mm, and the extension is nothing but change in length, that is the 0.085 mm, and the change in diameter delta d 0.003. So then first we have to calculate the Young's modulus. We have to calculate. For this one, first we have to determine the linear strain. So we know the formula, linear strain is stress divided by the Young's modulus. So here stress is load divided by the area. So load is given and cross sectional area also is given. So then we have to substitute load and cross sectional area. Then the linear strain, which will become the epsilon 1 equal to 81.49 divided by E, capital E. And also we can be determine the linear strain. So linear strain is nothing but change in length divided by the original length. Change in length is given, that is the 0.085. So original length is given 200. Then substitute, we will get the 4.25 into 10 to the power minus 4. Then we have to equate these two equations. From these two equations, we will get the E value. Then we have to equate these two equations. That is the 4.25 into 10 to the power minus 4 equal to 81.49 divided by E. So from this equation, we can be find E value is the 1.197 into 10 to the power of 5 Newton per mm square. So next one is we have to calculate the Poisson ratio. So what do you mean by Poisson ratio? Poisson ratio is the ratio of the lateral strain to longitudinal strain. So in the previous, we already determined the longitudinal or maybe the linear strain. That is the change in length divided by the original length. That is 4.25 into 10 to the power of minus 4. Similarly, next we have to determine the lateral strain. So lateral strain is, let us consider the epsilon 2, that is change in diameter divided by the original diameter. That is the change in diameter is given in data, that is the 0.003, and the original diameter also given, that is the 25 mm. So from this one we will get the lateral strain, that is the epsilon 2 equal to 1.2 into 10 to the power of minus 4. Then I have to substitute epsilon 1 value and epsilon 2 values in the Poisson ratio equation. So we will get the Poisson ratio, that is the 1 by m equal to 0.2823. So from our convenient to determine the bulk modulus and the shear modulus, we can be determine the m value. So from this above equation, we will get the m value is the 3.542. So next we are going to calculating about the G value, shear modulus. In the previous lecture, we know the relationship between the Young's modulus and the shear modulus. So that is the Young's modulus, that is capital E, equal to 2G into 1 plus 1 by M. So we already determined the E value and also 1 by M value or maybe M value. We already determined. So this equation E equal to 2G into 1 plus 1 by M. This equation can be written as the in the terms of the G. So that is the G equal to, here I have to take the LCM. So M plus 1, here M. So M into E divided by 1 plus M into 2. So we will get the G value. So we know the M value and E value. So then I have to substitute in this equation. We will get the G value, that is the 0.748 into 10 to the power of 5 Newton per mm square. So next we have to determine the bulk modulus, value of the bulk modulus. So we know the relationship between the bulk modulus and the Young's modulus, that is the E equal to 3K into 1 minus 2 by M. So this equation can be write as in the terms of the K. So that is the K equal to, so ME divided by 3 into M minus 2. So here we have to substitute the M value and E value. Then we will get the K value is the 1.468 into 10 to the power of 5 Newton per mm square. Thank you.